Hello everyone. This is part 2 of the Sizing Purified Water Systems video tutorial series. If you haven't watched part 1 already, please make sure to do so, as in that video I provided general information about WFI systems and also discussed how to generate and access the appropriate resource and inventory charts using SuperPro Designer. In this video, I'll discuss how to use SchedulePro to size purified water systems. Also, if you don't have SuperPro Designer or SchedulePro, please make sure to download the trial versions of both tools through our website www.intelligent.com. Let me now switch to SchedulePro to continue the tutorial. To start off, it is important that I mention a significant difference between SuperPro Designer and SchedulePro in terms of resource tracking. In SuperPro Designer, you're able to track the resources, WFI in this case, of a single integrated process and use the information generated to size a WFI system for that process. In SchedulePro, however, you're able to track a resource for a multi-product, multi-purpose facility where different processes that require WFI are carried out. To demonstrate how to use SchedulePro for WFI system sizing, I will use an example where two different monoclonal antibody production processes are carried out in the same facility, both requiring WFI. Each of the processes uses their own main equipment but shares CIP skids. In the Explorer tree, you can see the two different recipes. The first one is called Monoclonal Antibody 1, Map 1, and the second one is called Map 2. Recipes are made up of a number of unit procedures, and procedures consist of a number of operations. Unit procedures can be defined as processing steps composed of a set of operations that take place in a piece of equipment. In order for SchedulePro to be able to track a resource, the resource must be assigned to the operations of the recipes. However, before we can assign a material to an operation, it must first be created. Materials are specified by selecting the Materials node of the tree, clicking on the Add New Materials button, and then specifying the material that you want. Here you can see that a number of materials have already been specified, including our WFI. Once you have added the material, you can proceed to assign it to the operation or operations that utilize it. To do that, first select the unit procedure with the operation of interest. We can select media blending in this case. And then bring up the operation dialog by double-clicking on the operation. I'm going to select the CIP operation in this case. Now to add material consumption, we need to choose the material input tab, which is this one here. As you can notice here, there are several material inputs that have already been added to this operation. To add a new material input, you need to click on the Add New Input button, and through the dialog that appears, you need to specify the material's input information. Let's say, for example, that we would like to add WFI to this particular operation, so I just type the name WFI. I can specify the type of material. This is a bulk material, not a discrete one, so I just leave it at bulk, and I specify the amount. Let's say that I would like to specify 100 kilograms. I type 100, and then I need to specify the composition of the input material. To specify WFI, I select it from the list and double-click on it to register it as the component related to this input. Once I click OK, your newly defined input will appear in the list as well. Furthermore, to delete a material input, you first select it and then click on the Delete button. Let's bring up one of the previously defined inputs to see how it looks like. Here you see that we're adding a mixture, so we're adding phosphoric acid mixed with WFI. Please note that you can create mixtures here, or you could also predefine mixtures when adding a new material. Let's now click Cancel to exit this window. At this point, it is important to mention that to accurately track WFI requirements, a material input for all of the different operations that utilize WFI needs to be added. After adjusting all the material inputs, you can proceed to generate resource consumption charts. However, resource profiles can only be displayed once you have created a production schedule through the specification of campaigns. You can do that by going to your production schedule branch of the tree, and defining your different campaigns. In this example, we're carrying out a campaign of 6 batches for the production of our monoclonal antibody 1, and we're also carrying out a campaign of 5 batches for our recipe of MAP2. After scheduling the campaigns, you can generate the resource profile charts by going to View, Resource Profiles, and then selecting the option Raw Materials. In this dialog that appears, you have to specify the material for which you would like to generate the chart. From the drop-down list through the Materials tab, we have to select WFI and press Plot. This brings up our chart. Alternatively, you can also generate resource profiles by first opening up the equipment occupancy chart, which you can bring up through the main menu using this button. And let me first expand this chart a bit. And then using the Resource Chart button, which appears on the top right-hand corner. To bring up the chart, we then click on that button and select the option Raw Materials. And again, we need to select our material, which is WFI, from the drop-down list. And again, press Plot. Moreover, you can link this chart to the equipment occupancy chart by clicking on the Link button on the top left-hand corner. That is this button right here. And as you can see, the chart automatically links to the other one. Furthermore, we can zoom into the chart. So let's say that we want to see everything in more detail. And when we scroll, you'll see that both charts scroll together. Notice that there are 3 different profiles in the resource chart. These are the instantaneous demand, which would be the red line. The green line represents the cumulative demand for a certain time interval, and it corresponds to the y-axis on the right-hand side. And finally, the blue line represents the average rate demand for a certain time interval. However, when you first open this chart, it only displays the instantaneous demand, just as we saw in the first video with SuperPro Designer. In order to add the cumulative and average rate demand, a time interval needs to be specified first. To do that, you can right-click on any empty area of the chart, and in the menu that pops up, you can select Edit Style. Through this dialog, you then need to check the options Include the Rate Average line and Include the Cumulative Amount line, which are already checked here, and then specify a time interval for the generation of the charts. Again, these 3 lines provide enough information to size a WFI system. The tallest instantaneous demand peak, which would be this peak here, provides enough information for sizing of the WFI delivery system. The highest cumulative demand peak, which corresponds to the green line right here, gives us information for sizing the storage tank. And finally, the tallest average demand peak gives us information to design the still. Besides demand charts, inventory charts can also be generated with SchedulePro. To do that, we first need to define a material supply system. This can be done by selecting the Material Supply System branch from the Facilities node. So I need to expand my facility, and then I choose the Material Supply System option. And through the window at the right-hand side, I can add my material supply system. Here you already see a system for WFI. To view its properties, we can double-click on it. All the information that you need to provide to define your material supply system can be done through this dialog. The basic information includes the name and the material that is supplied. Furthermore, through the Inventory Data tab, you need to specify your inventory capacity, in this case this 30,000 kilograms, and also your opening inventory. The information from capacity can be obtained from the tallest cumulative peak from the resource chart that we saw a few moments ago. In addition to this information, we also need to specify replenishing limits and production rate. This can be done by going to the Replenish Data area and clicking on your Replenish Data button. Here you need to specify the production rate amount in this area, and you can also specify your on and off trigger, which in this case corresponds to 35% for the on level and 100% from the off level. So what this means is that when the storage tank reaches the 35% limit level, it will start producing WFI, and it will turn off once the tank is full. Periodic replenishing is also possible, but for this example I'm only going to focus on continuous replenishment. Another important thing to mention is that a Schedule Pro project may include any number of WFI systems, each supplying different processes or parts of a process. To view and specify which material supply system supplies the different processes, you need to bring up the View Uses of Material Supply Systems window by clicking on this button. This dialog that pops up can then be used to edit the streams that are associated with a material supply system. If we click on a specific recipe, we can see the different streams that are supplied by this system and the procedures to which the streams belong to. Through this area, you can include and exclude streams, which gives you the possibility to assign supply through various systems. In this example, we only have one material supply system. Another feature which you can apply to material supply systems is downtime to account for loop sanitization, for example. Downtime can be specified through a calendar system by clicking on this button. Through this dialog, you can specify when a downtime is carried out and its repeat pattern. When a WFI system is down, operations that draw WFI from that system cannot be executed. With your material supply system defined, you can now proceed to generate inventory charts. Again, you can do that by going to View, selecting Inventory Profiles, and then selecting Material Supply Inventory. Alternatively, you can first generate your equipment occupancy chart, clicking on the Inventory Chart button, and then selecting Material Supply Inventory. Then, through this dialog that appears, you can select the adequate supply system, and finally click Plot. This will generate the chart. Inventory charts can also be linked to the equipment occupancy chart in the same way that we saw with the resource chart. So that would be clicking on the link button. Notice that in the inventory chart, we have two lines. The green line corresponds to the inventory of WFI, while the blue one corresponds to its production profile. Furthermore, Schedule Pro allows you to link more than two charts together. So let's bring up the research chart. So we can generate here through raw materials, go to materials, select our WFI, press plot, and then press on the link button, which would be this one here. And now you see that all charts are linked to each other. An interesting thing to mention about the linking feature is that if we make a change in the way our batches are carried out through our equipment occupancy chart, the first one above here, so let's say for example that I want to move this batch a little bit later, the program automatically will update the WFI research chart and inventory chart. That also means that if we add more campaigns, the changes will be taken into account. This completes this video tutorial series on the sizing of purified water systems. Please remember to visit our website www.intelligent.com, where you can download literature where this concept is explained in more detail. I hope that you found the video useful, and thank you very much for your attention.